يعطيكم العافية شباب مرة أخرى. نستكمل حديثنا عن المارتن ستاتيك ترانسفورميشن. مارتن ستاتيك ترانسفورميشن قلنا المارتن سايت forms upon quenching fast cooling. Last thing we mentioned was about the effect of percent carbon on MS and MF, starting temperature for formation of martensite, will finish temperature for formation of martensite. And we mentioned that ذكرنا إنه as carbon content increase, the MF and MS increased accordingly. خلينا نذكر بعض الأمثلة بالنسبة لعلاقة نسبة الكربون بالريتيند austenite. احنا حكينا انه not all austenite transforms to martensite. Some of austenite is still transformed, and we call it retained austenite. The retained austenite, what's the relationship between the retained austenite and percent carbon? Actually, for example, eutectoid steel. For eutectoid steel, which has a 0.78% carbon, the retained austenite in percentage almost, if we have after a transformation of austenite to martensite, the remaining austenite which is not transformed, its percentage of about 6 to 10% retained austenite, while almost below this, أقل من هاي النسبة, less than almost 0.6%, the retained austenite percentage is insignificant, غير قليلة نسبة retained austenite below this percentage. Higher than this percentage, up to, let us say, let us say up to percent carbon between 0.6 and 0.95. They found it if the percent carbon within this range, they found that there is almost 13% returned austenite. Of course, after this percentage, for example, at 1.4% carbon, they found it very high percentage of retained austenite. So from these notes من هاي الملاحظات the relationship between the retained austenite and the percent carbon, if we draw the relationship between the hardness and percent carbon for martensite, we found it something like this. As the carbon content increases in the martensite, the hardness increases up to maximum value at almost 0.5% carbon. After the 0.5% carbon, the hardness decreases again. So as we mentioned before، زي ما ذكرنا سابقا، بأنه نسبة الكربون the percent of retained austenite below 0.6 is insignificant، غير مهمة. That means the amount or quantity of austenite or retained austenite is not much، كمية قليلة. retained austenite, of course, it's very soft compared to martensite. So when its amount is small، لما كميته تكون قليلة، that means the value of hardness for martensite will be higher. Then after this percentage, the amount of percent of austenite increases more and more by increasing carbon. So the hardness of martensite will be decreased. What we want to say also about martensite is metastable phase. Metastable phase above room temperature. Metastable phase above room temperature. So for long, when we leave a martensitic steel structure at room temperature for a very long period of time، زمن طويل جدا، it may transforms or decomposes the martensite. Why? Because it's metastable phase above a room temperature, above a room temperature. One more difference between the periodic transformation and Martensitic transformation. We mentioned before there are differences عندنا اختلافات between two types of transformation. The periodic transformation it's diffusion. The periodic it's diffusion controlled process, while Martensite it's diffusionless. Diffusionless process. This is one difference between periodic and Martensitic transformation. Another difference here, there is a periodic incubation period. Incubation period. Here, no incubation period. This phase, it's equilibrium phase. Equilibrium phase. This phase, it's Martensite is not non-equilibrium phase. Non-equilibrium. Non-equilibrium phase. These are some differences. Other differences, important differences also. In periodic transformation, as I mentioned before, after austenization process, then cooling, nucleus or nuclei, NOA of nuclei or nucleus of ferrite and cementite in a layered structure. Forms at grain boundaries. Then these nuclei grows. I mentioned that before. ذكرت هذا من قبل. There is a nucleation and a growth of a nuclei. At the same time, بنفس الوقت, while this nuclei or this nucleus هينوع grow, تنمو, at the same time, other nuclei of ferrite and cementite grows, forms and grows. So the initially formed grain nuclei النوع اللي تكونت في البداية استمرت بالنمو بينما تتشكل نوع أخرى. هذا كلام in Martensitic transformation does not occur, ما بحدثش. اللي بحدث إنه we can say that بإمكان القول بإنه initially خلينا نكتب the initially formed plates of martensite do not grow with time. بالعكس البيريودك transformation to grow with time. This is differ from the periodic transformation where in new colons بسميناها colons يعني grains colons nucleate while old ones or colons continue growing. This is in periodic transformation. النوع القديمة تستمر بالنمو بينما تتشكل في الوقت نفسه الذي تتشكل فيه نوع جديدة. وهذا اللي ما بيحصلش في المارتنسيتك ترانسفورميشن اللي تتوقف فيه مباشرة مجرد ما تشكلت البليتس هاي أو مارتنسايت it do not grow or they are do not grow لا ينمو وتتشكل إيش بليتس جديدة. Okay. Now we go further نذهب أكثر عمقا بالنسبة للبيريودك ترانسفورميشن مارتنسيتك ترانسفورميشن وبنقول إنه المارتنسيتك ترانسفورميشن زي ما ذكرنا لكم سابقا بأنه it's diffusionless process بمعنى we are not asking the atoms to diffuse. There is no diffusion for carbon atoms. Diffuse. We are not asking atoms to diffuse. ما بنقول الاتومز انها يصير لها diffusion, just being displaced إزاحة من displacement فقط بيصير الكربون اتومز عملية إزاحة ولكن هاي الإزاحة by only small distance بإزاحة مسافة صغيرة جدا. قديش يعني هاي المسافة الصغيرة؟ هي عبارة عن جزء fraction of interatomic spacing. يعني هاي اتوم باي اتوم هاي الانتراتوميك spacing between two atoms قديش هاي صغيرة المسافة هي جزء من هاي المسافة فقط بصير في إزاحة جزء صغير من هاي المسافة فقط بصير إزاحة الكربون اتومز. وبهاي الازاحه الصغيره للكربون اتومز الكريستال ستراكشر changes. So the crystal structure changes. So the crystal structure changes. How it changes? Chemical structures. The crystal structure changes from austenite, which has FCC crystal structure, to Martensitic. Usually we refer to Martensitic. We refer to it as alpha prime. Alpha prime is Martensitic. Alpha from ferrite. Ferrite has PCC structure. Martensitic also have PCC structure, but with different lattice parameters. So since the lattice parameters are different, we do not call it PCC, we call it PCT. Body center tetragonal. Body central tetragonal. Body central tetragonal. We will clarify this. How the FCC crystal structure of cementine transforms to PCT body centered tetragonal, which forms Martensitic face. So in next lecture, our next video, we continue with Martensitic transformation and show you how the FCC crystal structure of stone transforms to body centered tetragonal, which is the crystal lattice or the lattice structure of Martensitic. يعطيكم العافية شباب مرة أخرى. نستكمل حديثنا عن المارتن